Many times as a structural engineer, you are required to do quick rough calculations, especially over initial discussions with the architect or any other consultant that you're having. In those cases, you need to make approximate calculations which can give you a fair insight about the concrete capacity that you have. So let's take an example. Let's say you have a section which is probably governed by flexure, which is of width b and depth d, and let's say you are having a moment m in this particular case. And let's say now if you want to work out the typical reinforcement that we have, so let's say as per typical uh, singly reinforced section, how much would be the capacity of this particular section, or what would be the reinforcement needed for to support this moment that you have. So that can be quickly calculated as 4.6 times mu divided by fck bd square. This you need to have in negative sign and quickly have as under root of. Further, you need to further divide by deduct this by 1 and then multiply this particular expression by zero point 0.5 times b times d times fck divided by fy. Fy is the yield strength of the reinforcement that you have. This is expression is based upon IS 456, which is the Indian concrete design code that you have. Similarly, you have expression based on Euro code and US code also. The only the factor could vary, and rest of the things can be here and there similar. This will give you a typical reinforcement that you have, assuming it's a singly reinforced section. What you need to be careful about that about the units of this particular expression. So the AST that you will get out of this particular, which is the area of reinforcement that you get out of this particular expression, you need to have convert this into Newton Newton meter to have a correct answer. So which is basically typical kilonewton meter moment needs to be converted into Newton millimeter, which will you'll have to multiply this by 10 to the power 6, and this will give you a typical reinforcement in millimeter square per meter that you're having, or millimeter square depending on the the loads that you have. So that can be a quick trick or quick expression which you can do over a calculator and arrive at the typical reinforcement that you need for a given section that you have. Okay, this does not factor in the serviceability requirement that you have, but it can only check the ULS flexure case that you have. Similarly, let's take an example where the section is governed by shear, or let's say you are having shear capacity calculation to be done, and let's say the typical depth of the width of the section is b and the depth is d. So in that case, how do you compute the shear capacity? So let's say the section is having a shear v. So first we'll need to compute how much would be the capacity of the pure concrete section that you're having. So typical thumb rule which is followed, or which you can follow, that is tau c, which is the capacity of pure concrete and shear, can be taken as zero point 0.3 MPa or zero point 0.3 Newton per millimeter square, which is the maximum shear concrete can take purely. So if you need to compute the contribution from concrete, it will be VC, which is the shear capacity that you're getting, which is tau c times B times D, which is the shear area that you're getting. So whatever the capacity that you have out of concrete will be given by this. Further, whatever left, which is V dash, would be given by V minus VC, and then you can quickly just whatever expression that you get out of it, if you just equate this times as 0.87 Fy times D, it will give ASV, which is the reinforcement that you're having, times SV times D. This will give you the, if you work out the reinforcement from this, it will give you the right away expression needed for the shear reinforcement. Similarly, let's take another example whereas let's say you are having a column, and that column is actually loaded with a vertical load, and it is mostly predominantly a stocky column. It is not slender. So you can quickly calculate the capacity as per IS 456, which is the axial capacity that you have, as zero point 0.4 FCK times AC, which is the plus, this is the contribution of concrete, then 0.67 Fy times AST, which is the contribution of reinforcement that you are having. So this will typically give you the capacity that you have particular column, assuming it's a stocky column, it is not slender. If it's slender, the buckling analysis needs to be done. Okay, then the last example that we have, which is let's say if a concrete is having pure tension. In this case, when you have pure tension, the concrete is not participating at all, and let's say you are left with a tension in the concrete as T. Now how do you calculate quick reinforcement? So which is basically you right away need to equate this, which is the reinforcement itself will be participating. So you only need to just equate this as Fy and deduct it with the factor of safety for concrete that we have, which is 1.15 times AST. This will quickly give you the reinforcement that you need, which is in pure tension. So let's say if Fy is 500 and this 1.15 will turn out to be 0.87 only, and AST you will be right away left with whatever reinforcement that you have. Okay, so that can quickly give you the reinforcement needed based on this. So this was a quick hack which you can follow, especially doing with some thumb rules and quick calculation to do concrete design, which in specific situation just to have a rough approximation of the results. Hope you found the video helpful. Press the like button and subscribe for more.